All right, team. It's now time to see the awesome power of graphical solutions and how we can use a graphing method to solve challenging problems like this one. Several people were able in class to solve this question using a guess and check method. But right now, we're going to use a graphical method to solve this type of problem. The first step is we need something that we can graph. We could just start plugging in stuff for like the value of hot dogs. Like it would look like this: let hot dogs cost $2, and then you would say four. Then you would start working here. 4 times 2 would be 8. The 5 hamburgers must cost $25 minus 8. They must cost $17. So hamburgers in that case would be 17 over $5 each, which is awkward. That would be $3.40, which is kind of cool. That's not the solution. We'll find that that wouldn't work in here. But that would give us points, and if we did that a couple times, we'd have points we could make a line. Now I'm going to show you graphical. First step is to make equations, and we're going to say let x equal one of our unknowns, and let y equal the other unknown. Okay, what are our unknowns? We don't know how much a hot dog costs, and we don't know how much a hamburger costs. So let's say let x equal the price of a hot dog, and let x equal the price of a burger. Now we can build equations. We're going to build an equation from the first situation first. And so I know hot dogs, we now call that x, and hamburgers, we call that y. Okay, that's a little bit ugly, but it's here we would have 4 hot dogs plus 5 hamburgers equals $25. Is one of our equations. The other equation will be done in blue and will be 6 hot dogs. You'll notice it's from the next sentence. 6x plus 3y equals 24. All right, now, if I want to use graphing, I can graph these lines, but it's really a lot easier if I convert them to y equals mx plus b form first. So to convert this from y equals mx plus b form, I'm just going to slide the page up, give myself some nice room to work in, and then I'm going to say, well, I'm going to use inverse operations to transform this into y is equal to, there's going to be a series of steps that I'm going to use to make y equal to some number multiplied by x plus some number. Okay, these are easier to graph, y equals mx plus b form. So to graph this, I'm going to convert to y equals mx plus b. My first step, subtract 4x from both sides. That will now give me the line 5y is equal to 25 minus 4x. And this should make sense. The price of 5 burgers, that's it there, is equal to $25 minus the cost of 4 hot dogs, okay? Which is what we had before, right? Now, instead of writing it this way, I am going to write it this way, negative 4x plus 25. I'm just going to reorder that so that it matches my mx plus b. It's just a habit. It's the same thing. It's not different. Now, last thing to do is I don't want the price of 5 hamburgers. I want the price of 1 hamburger. So in order to clear that 5, I use the opposite of multiplication, which is division. That will be 5 divided by 5 is just 1. And so I'm just left with y on that side of the equation. And then over here on this side, I just need to make sure to divide both terms by 5. That's one term, that's another term, connected by addition or subtraction, okay? So, negative 4 over 5, no way to simplify that except as a decimal, so I'm going to leave it as negative 4 over 5x plus 25 over 5. Well, 25 divided by 5 is 5. A fraction is just a kind of division, so that's 5. So this says the cost of a hamburger is negative 4 over 5 times the cost of a hot dog plus $5. It's now at the point where it's a little bit tricky to understand, but we can graph that line. Now let's convert our other line. We're going to use the same set of steps. Minus 6x minus the cost of all those those hot dogs from each side to give us 3y is equal to negative 6x plus 24. Now we divide both sides by 3, divide both terms by 3, and y is equal to negative 6 divided by 3 is negative 2x plus 24 divided by 3 is 8. All right, cool. So now let's remember these equations. This one here, y is equal to negative 4 over 5x plus 5, and y is equal to negative 2x plus 8. Okay, and one moment, and I'll grab us a piece of graph paper. All right, we're all ready again, so let's go back over here. Here's our first line. Let's graph this one first. Y is equal to negative 2x plus 8. So the first thing that I know with this line is if I were to do a table of values, which you can write out if you're confused, some easy values to pick are x is 0. It's always the easiest. Notice that when x is 0, I have y is equal to negative 2 times 0, which happens to be 0, plus 8. Y is equal to 8 plus 0, 8. Okay, so here's the point 0 in the x, 8 in the y. So it's this point up here. Okay, so that's one of the points on this line. Next, I could go over 1, and then I would have y is equal to negative 2 times x, which is 1, which is negative 2. Y is equal to negative 2 plus 8, which would be 6. Basically, I went over 1 and down 2. So that there is the point 1 in the x and 6 in the y. Okay, let's do another point for fun, 2. Okay, I'll have y is equal to negative 2 times 2 plus 8. Negative 2 times 2 is negative 4 plus 8. Negative 4 plus 8 is 4. So that will be this point here. That's 2 in the x and 4 in the y. So now I have this set of points that are the infinitely long set of solutions to this situation. There, just trying to get it nice and accurate there. So those are all the solutions to this equation, an infinite number of them. Now let's graph this one. But before we do, let's observe something about this. When we were graphing this, we went over 1 and down 2, okay? This is plus 1 in the x, negative 2 in the y. And this number here gives us that. It's negative 2, which is the same thing as negative 2 over 1, which is the rise, or change in y, over the run, or change in x. So that's how we can, after graphing the y-intercept, which is this number, that's where it touched the y-axis, was at 8. Then we graphed the rise, which is negative 2, and the run, which is 1. And that's how you can get your 2 points to graph these lines rather quickly. Now let's go ahead and graph this one in purple. Okay, I'm just going to recopy that line over here, and I'm going to give myself some space because we don't need that table anymore. Here we go, folks. Let's write this line out. Y is equal to negative 4 over 5x plus 5. First thing I'm going to focus on is this point 5, and I'm going to put it on there. It's just that easy. This is the point 0 in the x and 5 in the y. It's right there. Okay, now I am going to use this idea. Negative 4 over 5 is my m value. That's called the slope. That is, in other words, rise over run. So with fractions like this, it's very helpful to use this idea instead of a table because I can run 5 and rise negative 4 to graph this line. So from here, I'm going to run 5. From 0, I run 5 out to 5 here, and then rise negative 4. So I go from 5 down to 1. This is the point 5 in the x, 1 in the y. Then I create a line from here to here, and I keep going, sure, why not? And that will give me, here is the solution. What does that mean, the solution? Okay, these were all the possibilities from the second order of values for hot dogs and hamburgers. This is all the possible values in the first order. This is the only point that those two situations share. So that is the solution. What is it? Well, we want to write it as a point. It's 2.5. Notice it's 2 and a little bit. This is 2. This is 3 here. And this one happens at 2.5. Okay? 2.5 in the x and 3 in the y. This is our solution. That's what we've been looking for this whole time. Let's go up and see what that means. 2.5 is x and 3 is y. Well, we let x be the price of a hot dog. $2.50 is the price of a hot dog, and y is the burger. $3 is the price of a burger. Let's check our work, okay? Let's take the first one, the first situation, and then we'll say 4 times the price of a hot dog, 2.5, plus 5 times the price of a burger should equal $25. 4 times 2.5 happens to be $10. 5 times 3 happens to be $15. So 10 plus 15 does in fact equal 25. So that's a point that's satisfying this line here. How about this one? Let's test this one. 6 times 2.5 happens to be 15. No, 16. Anyway, I'll check on in a second. 6 times 2.5 plus 3 times 3. Does that equal 24? Well, in fact, it does. Because 6 times 2.5 is 15. Check it on a calculator if you don't trust me. And 3 plus 3 is 9. So that is 24. So it satisfies that one. And notice it's the only combination of hot dog prices and hamburger prices that satisfies both. That's our solution. That's what we're looking for. The last thing to do to tie a bow around this lovely question is a nice therefore statement. We probably should put it at the bottom of our work to help a math teacher who's looking at the bottom of our work for our answer. And this is what a therefore statement should look like. Therefore, the hot dogs, the dogs, cost $ first, please, 2.5, 2 decimal places, please, with money. And the burgers cost, spoiler alert, we already had this, $3. Done. End of question. Any questions, hit me up by email or chat with me live because you have access to me live right now, all you busy math folks. Hope your math practice is fruitful today.